Hi, I'm Rebecca Ringett from the Community Coordinated Modeling Center, and here I'm going to show you how to use the Satellite Constellation Mission Planning Tool, also known as the Reconstruction, to perform mission planning for irregular constellations. So the Reconstruction tool itself doesn't support creating an irregular constellation. However, you can pull these pieces together yourself quite easily. So for this demonstration, what I'm going to do is I'm going to choose as many satellites from the DMSP constellation as is covered by the model data that I have on the computer. All right, so the model data that I have, in this case for WAM-IPE model, is for the storm that occurred in March of 2013. I can get the start and end times of my model data coverage using the same function as before, shown in the other videos and the other notebooks. And I get the timestamps for that with these simple commands. So knowing that this data covers March 16th through March 21st, I can look in this little table here, retrieved from the SSC website, Satellite Situation Center website from GSFC, Goddard Space Flight Center, and figure out which satellites are covered by that time range. And if you look through here, you'll figure out that that'll be satellites 15, 16, 17, and 18 that were flying during this March 2013 storm. Okay, so what I'm going to do is pull in those real satellite trajectories into Python memory using the satellite trajectory fly-through function, which returns the information in a dictionary right here. And I'm pulling those in the geographical coordinate system, which is the coordinate system that I want the construction to be performed in. All right, we'll get back to that in a minute. You can piece these together simply by appending one trajectory on the end of the other for each of the four coordinates, time, X, Y, and Z, just like this with this code. And we can take a look at that using the SatPlot 4D plotting code available in the flythrough.plots module. Okay, so this plots it in geographical Cartesian coordinates, where the color in this case indicates just time and hour since midnight of the first day of the trajectory. Okay, right. Now, the reconstruction, we want to do the reconstruction in spherical coordinates in this case. It's not always the case, but in order to do that, you need to convert that input trajectory into spherical coordinates. So I'm not changing the coordinate system. It remains to be geographical, but I'm changing it from Cartesian to spherical in this statement here. Once I have those changes in place, you can simply input it into the reconstruction call. Remember to choose your variable name, what dimensions you want the reconstruction performed in, and the reconstruction option here. You also need to remember to choose the resolution of the grid that you want used in the reconstruction. And if you're averaging over multiple slices, choose the resolution that you want, or rather the sampling that you want for those averagings. All right, and then you run the reconstruction command as normal. In this case, it has reconstructed what such a satellite constellation would see if it were observing TEC. Now remember that TEC does not depend on height ever, because it's a height integrated variable. So that's why the sampling here of 1 Earth radii is chosen, because height doesn't matter for TEC, total electron content. Okay, so the reconstruction is performed for the 4 satellite constellation, DMSP, for 15, 16, 17, and 18 satellite numbers. And then we can compare it easily to what the model predicts. So this is the default Kamodo plot for the given reconstructed data. You can plug this command right here into a slightly more complicated piece of code here. Just plug it in here, however, whatever plotting command you have, and it just smooths the color over so you can see a little bit more detail in the data. Okay, so that's what the satellite is predicted to see, the constellation and this is what the model data is predicting. So the science user can compare this plot to this plot and determine, well, is this enough of a constellation? Or is this the right number of satellites? Or is this the right arrangement of satellites, and so on, to detect what I want to see? What you might notice is that you see this trend in both of them, but you don't see this little black area here that is predicted here and here. You can't resolve that. All right, finally, this is the same percent difference plot that you see in the introductory notebook here in the smoother color scheme. All right, so that's the end of this tutorial. Stay tuned. Grab your version of Komodo, grab your model data, and start working and having fun. See you in the next video.